In this video, I'm going to show you how to solve some exponential equations. Now, before we do that, we need to make sure that we are 100% up with our rules of indices. So we know we're going to be using the fact that if we have a to the m to the n, then that is a to the m times n. We're going to be using the negative indices, so a to the minus n is 1 over a to the n. We're going to be using roots, so a to the 1 over n is the nth root of a, and a to the m over n is the nth root of a to the power of m. Our strategy for this, we'll take a simple equation to start with. 2 to the power of x equals 16. Now, a lot of people can just look at that and see what the answer is, but our overall strategy is to look at the base number, which in this case is 2, and write both sides as 2 to the power of something. So we would write this 2 to the power of x equals 2 to the power of 4. Once we have it in this form, we can say, therefore, x equals 4. It's important that we do have just 2 to the something equals 2 to the something else. So, for example, we can't have 2 to the x times 2 to the 1 equals 2 to the 5, and then say x times 1 equals 5. In this case, well, we might as well just solve this one. We would have to rearrange it. 2 to the x plus 1, using another rule of indices, equals 2 to the power of 5, which means x plus 1 equals 5, x equals 4. I wasn't sure if we were going to use that rule, but we are, so I'll write it over here. A to the m times a to the n equals a to the m plus n. Okay, let's just race through a few more of these, hopefully with some harder rules to deal with. Suppose we have 4 to the x plus 1 equals 64. We can actually write both of these as powers of 4, because we know that 64 is 4 to the power of 3, so we can say that is 4 to the x plus 1 equals 4 to the 3, hence x plus 1 equals 3, x equals 2. Now there's another way we could have approached that question, and that is by reducing everything to 2's. So let's write the question out again. We can write 4 as 2 squared to the power of x plus 1. 64 is 2 to the power of 6. Now we can apply the top index rule over here to the left-hand side. It gives us 2 to the 2x plus 2 equals 2 to the 6. Now we can say 2x plus 2 equals 6, 2x plus 4, x equals 2. Okay, let's try and make these slightly harder. Let's go 3 to the x plus 1 equals 1 over 27. Two things going on here. Whenever you have a 1 over, I would write it like this. So 1 over 3 cubed is 3 to the x plus 1. So what I'm saying is deal with each thing separately. So we also know from the second rule here, 1 over 3 cubed is 3 to the minus 3. So 3 to the x plus 1 equals 3 to the minus 3. Now we can say x plus 1 equals minus 3, x equals negative 4. I should have said, by the way, pause the video each time I write a question and try it yourself if you feel confident. Let's say 2 to the x minus 2 equals 1 over 64. Well, 1 over 64 is 1 over 2 to the power of 6, which is 2 to the minus 6. So we have 2 to the x minus 2 equals 2 to the minus 6. So x minus 2 equals minus 6, x equals minus 4. Just ramp this up with some slightly harder questions, which is to say harder rules of indices. So suppose we have 8 to the power of x equals 16. I mean, it's sort of tempting to go, well, it's times by 2, isn't it? But no, we need to reduce everything down to a common base, which in this case is 2. So 8 is 2 to the power of 3 to the power of x, and 16 is 2 to the power of 4. We then have 2 to the power of 3x equals 2 to the power of 4, which means 3x equals 4 and x equals 4 over 3. What we're saying there is that 8 to the 4 over 3 equals 16. This means we take the cubic root of 8, which is 2, and then we raise it to the power of 4, giving us 16. Okay? Just to explain what that solution means in context. Okay, let's try 4 to the power of x equals 1 over 32. Again, try this out if you like. We'd have to go 2 squared to the power of x equals 1 over 2 to the 5. That gives us 2 to the 2x equals 2 to the negative 5. 2x equals negative 5. X equals negative 5 over 2. And again, what does that mean? Let's just squeeze this in here. 4 to the minus 5 over 2 is 1 over 4 to the 5 over 2. We take the square root of 4, so it's 1 over 2 to the power of 5, which gives us 1 over 32. This final step, I'm just explaining how that works. Like, as in what the answer means. Now, we can make this tricky by putting some surds in here. So 4 to the x plus 1 equals 8 root 2. So, again, dealing with one thing at a time. We can see 2 is the common number here, so we're going to go 2 squared to the x plus 1. 8 is 2 to the power of 3, and root 2 is 2 to the half. On the left-hand side, we expand the bracket, so to speak, so we get 2 to the 2x plus 2. Here we are using that bottom rule of indices. 3 plus a half is 3.5, so 7 over 2. 2 to the 7 over 2. So now we're solving 2x plus 2 equals 7 over 2. 2x, so we take away 2, which is taking away 4 over 2, leaving us with 3 over 2. Divided by 2, we have x equals 3 over 4. Let's try 9 to the 2x equals 1 over 3 root 3. Okay, we see 3 is the important number here, so we've got 3 squared to the 2x equals 1 over 3 to the 1 times 3 to the half. So on the left-hand side, 2 times 2x is 4x. Over on the right, we have 1 plus a half is 3 to the 3 over 2, which means we have 3 to the minus 3 over 2. So 3 to the 4x equals 3 to the minus 3 over 2. 4x equals minus 3 over 2. X equals minus 3 over 8. Let's do a similar one to that. Let's say 4 to the 2 minus x equals 1 over 2 root 2. Well, we have 2 squared to the 2 minus x equals 1 over 2 to the 1, 2 to the half. So that's 1 over 2 to the 3 on 2. On the left-hand side, we have 2 to the 4 minus 2x. On the right-hand side, it's 2 to the minus 3 on 2. So we deal with the negative very separately from everything else. That is dealt with. So now we can say 4 minus 2x equals negative 3 on 2. Add 2x to this side, add 3 on 2 to 4. So that gives us 11 on 2. Divide by 2, we have x equals 11 on 4. Okay, suppose we have 8 to the 3x minus 1 equals 30, let's say 1 on 32 to the x. Again, we're going to reduce these to 2, so that's 2 cubed to the 3x minus 1 equals 32 to the minus x. which is 2 to the 5 to the minus x, which is 2 to the minus 5x. On the left-hand side, we're going to times 3 by that bracket, so we have 2 to the 9x minus 3. Now we have 9x minus 3 equals minus 5x. 14x equals 3, x equals 3 on 14. Getting a bit more interesting and complicated. Here's a nice example. 2 to the power of x times 8 to the 1 minus x equals 1 over 16. Again, reduce everything to 2, so we have 2 to the x, 2 cubed to the 1 minus x equals 1 over 2 to the power of 4. We have 2 to the x times 2 to the 3 minus 3x equals 2 to the minus 4. We've still got to combine that left-hand side to get just 1 2 to the power of something. So we're going to add the powers. 2 to the 3 minus 2x equals 2 to the minus 4. Now we can say 3 minus 2x equals minus 4. Add the 2x, add the 4, add the 4 better. X equals 7 over 2. Let's say we have root 3 to the power of x times 9 to the power of 1 minus x equals 1 over 3 root 3, or let's say to the power of x plus 2. Okay, do try this before you listen to me do it. If we're methodical about this, it doesn't matter how complicated it is. So we have 3 to the half to the power of x times 3 squared to the 1 minus x equals 1 over, now I've done this one so many times, it's 3 times 3 to the half, so we're going to do 3 to the 3 over 2 to the x minus 2. On the left, we'll go 3 to the half x times 3 to the 2 minus 2x. We'll do 1 over 3 to the 3 on 2x minus 3. That's all in the power there. It's getting a bit of a mess, but we can handle it. On the left-hand side, we're going to add those indices to give us 3 to the 2 minus 3 on 2x. And now we're going to times the index on the bottom by minus 1, which is a nice way of doing that. In this case is to, I don't know if flipping them is quite right. And oh, this is interesting. I think I've actually messed up this question, so it doesn't work. I was just picking things randomly. 3 minus 3 on 2x. Well, actually, yeah, this has no solution because we'd need 2 to equal 3 for that to work. So, oh well, I'm not going to delete it because I enjoyed the rest of the question up until that point. Last type of question we'll look at, we'll say 4, and this is a whole different approach now, because we look at this, equals 0. We can see 2 to the power of x is relevant, so we see that's 2 squared to the x minus 6, lots of 2 to the x. Now 8 is 2 to the power of 3. That actually doesn't help us because we can't pull all this together and have 2 to the power of something equals 2 to the power of something else. We can't combine, I mean I'll write it in there, we can't combine these terms because they're not being multiplied, they're being added and subtracted. So there's going to be no happy way, well, certainly no happy way based on what we've done so far to make all this work out. Instead, we're going to do a little bit of trickery. Now, 2 to the 2x, 2 to the 2 to the x is the same as 2 to the 2x, but that is also the same as 2 to the x squared. minus 6 lots of 2 to the x plus 8 equals 0. What we do now, we let y equal 2 to the power of x. So we have y squared minus 6y plus 8 equals 0. Now we factorize y minus 2, y minus 4 equals 0. So that means y equals 2, y equals 4. So 2 to the x equals 2. 2 to the x equals 4. We can just see here x equals 1 or x equals 2. So if we get something like this that we can't substitute, we can't approach using the 2 to the something equals 2 to the something else type strategy, look for those quadratic substitutions. And particularly in IB, that comes up a lot in other contexts as well. Let's see another one of these, which has a little bit more of a twist. We'll go 5 to the 2y plus 1 minus 9 times 5 to the y minus 2 equals 0. Now have a go at this, but it is quite hard. We've actually got to split this first term and say it's 5 to the 1 times 5 to the 2y. Okay, because then we can say it's 5 times 5 to the y squared minus 9 lots of 5 to the y minus 2 equals 0. So then we say let, in this case, x equal 5 to the y. So we have 5x squared minus 9x minus 2 equals 0. I'm going to factorize this using my favorite little trick here. Although in fact it's a bit unnecessary because there are so few factors. We can do this by trial and error. We know it's got to be 5x and x, and it's got to be 1 and 2. I'm going to go minus 2 there to give us the minus 10x plus 1. Pretty sure that works. Yes, it does. So we have x equals minus 1 on 5, or x equals 2, which means 5 to the y equals minus 1 on 5, and 5 to the y equals 2. Now, the one on the left looks like a negative power, but in fact, this one on the left here has no solutions. Okay, because if we've got 5 to the power of anything, it has to be positive. Let's remind ourselves what exponential graphs look like. This is the graph of y equals 5 to the power of x. So it's never negative. So this one has no solutions. Where we have 5 to the power of y equals 2, if you've already done logs, you'll know that this means that y equals log base 5 of 2. If not, that is something to look forward to for another time. But in short, it's not a nice rational number.